Welcome. These are the contents. First, internal components of CPU. What is CPU? CPU stands for Central Processing Unit. It is the primary component of computer that processes data and kernels and instructions from programs. The CPU acts the brain of the computer, performing calculation, logic, operation, and controlling the overall operation on the system. Component of CPU: ALU, arithmetic logic unit; CU, control unit; register, cache memory. ALU, arithmetic logic unit. ALU, arithmetic logic unit is the part of computer CPU which perform arithmetic and logical calculation. CPU may contain many ALUs, allowing the computer and conduct complex arithmetic and logic operation. CU, control unit. Control unit, brain of a CPU that manage computer's operation. Register in a CPU are small high-speed storage location that hold data temporarily during processing. These are used to store operands, intermediate result, and memory address. Register enable quick access to data for the CPU, enhancing processing speed and efficiently. Cache memory. Cache memory is supplementary memory system that temporarily stores frequently used instructions and data for quickly processing by the central processing unit of a computer. Function of a CPU: fetch, decode, execute, memory access. Fetch. The CPU fetch program instruction from the computer's memory or cache. Decode. It decodes the instruction and understands the operation to be performed. Execute. The CPU carries out the instruction performing arithmetic or logical operation. Memory access. It interacts with the computer memory to fetch or store data requirement for processing. How computer hardware component works. CPU. The CPU interpreted instruction and contributed operation. Arithmetic logic unit performs mathematical and logical conclusion, and control unit manage the execution and instruction. Storage devices: HDD and SSD. Long-term storage holds the operating system, application, and uses data. The CPU retrieves data from storage for processing and store result back. Motherboard: the central crucial board connect components. Effectively, communication buses of the motherboard allow data transfer between components. Graphic card manage graphics and visual output, especially important for gaming and multimedia. Cooling system: for fans of other cooling mechanism prevent components from overheating during operation. Memory means RAM. RAM stores active programs and data for quick access by CPU. Instruction and data are fetched from RAM during processing. Types of storage media and use of each. There are several various types of storage media, and each has specific use, depending on variables such as speed, volume, accessibility, and durability. Here are main types of storage media and their typical uses. Primary RAM. Computer use this type of volunteer memory to store and running machine code. RAM is crucial for operating system and application because it enables the CPU to access and retrieve data quickly when power is cut off. RAM losing in its content. Secondary storage types: SD card, DVDs, CDs, main storage, SSDs, HDDs, CDs. Usage: media storage, software distribution, and data backup. Second, SD card usage: storage for cameras, smartphones, and other portable devices. Last, SSDs, main storage for computers, laptop and servers. Data represented in computer system. Basic concept about data representation. In computer science, data representation refers to how machine process and understands various kind of data. Various information kinds call for various method for representation. A text document and a film, for example, will have listing representation. First, binary system. Information in represented using a base 2 system where each digit can be 0 or 1. Bytes. Basic storage unit components of 8 bytes. Bytes can represent storage numbers or other data types. Number system. Hexadecimal base 16 and octa base 18 are also used in compact representation, especially in programming. Image. Pixel value in images are often represented using binary with each pixel's color and intensity encoded. Sound. Audio data can be represented using binary where variation and amplitude over time are digitalized. Character encoding. ACII and Unicode are common stands for representing characters. ACII use 7 of 8 bytes to represent characters, while Unicode allows for border range and use 16 or 32 bytes. Encryption for represent data. Encryption is a process of converting data into source secure and unreadable format using algorithm and keys. How encryption works. Encryption is a complex process that transforms plain text readable data into cipher text unreadable data using mathematical algorithm. The main idea is to make sure that if someone gets their hands on secret code, they can't figure out what is say unless they have to special key. Types of encryption. Symmetric encryption, asymmetric encryption. Symmetric encryption use a single key for both encryption and decryption. Asymmetric encryption involves pair of key, public and private. Public key are encryption, private key are for decryption. How image and sound are represented in computer system. Image representation, pixel based representation, resolution and compression. Pixel based representation. Images are often represented as a grid of pixels. Resolution. Higher resolution means more pixel, resulting is a clear more detailed. Compression. Images are often compressed and reduced file size. Sound representation, waveform representation, sampling, digital audio format. Sound are represented as waveform. Waveform depict variation of air pressure over time. Sampling, analog to digital converting involves sampling and continuous sound wave at regular intervals. Digital audio format. Sound is often stored in digital audio format like WAV or MP3. How compression can aid the storage of data, images or sounds. Data compression, files compression, data transfer and storage. File compression. Lossless algorithms like zip and gzip are used to compress data files, allowing for more efficient storage and transmission. Techniques include run length encoding, Huffman coding and FL Welch LZW. Data transfer and storage. Compression reduces the bandwidth and storage space required for large files, making it invaluable for cloud storage, email attachment and storage distribution. Image compression, lossless image compression and loss image compression. lossless image compression. PNG and TIFF formats use lossless compression, ideal for image where quality preservation and essential. Example: medical images, design files. They employ techniques like leaflet and run length encoding. Loss image compression. JPEG is widely used for compression programs and achieve high compression radius by degrading less noticeable details. Techniques include degradative consume transform, DCT, and quantization. Sound compression. Lossless sound compression and lossless sound compression. Lossless sound compression format like FLAC and ALAC. Apple lossless compress audio without losing quality, suitable for audiophiles and professional audio work. They used methods like linear reduction and entropy encoding. Lossy sound compression. MP3 and AAC are popular format for compressing music and other audio. These format reduce file size by removing frequency less decodable by human ears. Techniques include respective coding and psychological models. Purpose of logic gate. Logic gates serve a fundamental purpose in digital electronics by enabling the multiplication and processing of binary information according to Boolean logic principle. These gates are designed to perform specific logical operations such as AND or NOT, NAND, NOR, OX, and XNOR, each governed by truth table that define output based on the input states O of 0 and 1 is. AND gate. All output AND gate. All input must be positive before the output is positive. OR gate. At least one input must be positive to give a positive output. NOT gate. Not simply accept an input and output the positive way. NAND gate. Same as AND, but the output is the inverse. Not so perform at AND first, then apply not to output. NOR gate. At least one output must be positive to give a positive output. All input could also be positive. XOR gate. Only one input can be positive to give a positive output. If both are positive, the output is negative. XNOR gate. All input must be positive for positive output, otherwise the input is negative. Different types of computer network. PAN, personal area network. LAN, local area network. MAN, manipulating area network. WAN, wide area network. Local area network. The purpose of local area network is to link multiple network system and device together over limited physical space. Multiple protocol and are used to connect the devices so that data and server can be exchanged efficiently and correctly. Wide area network. The purpose of wide area network is to link devices across the great distance, such as between states or nations. Most of the time the connection is wireless and communication by radio tower. Metropolitan area network. A network type that covers the network connection for a small area or full city is called metropolitan area network. A wired network such as one made of data cable connects the data networks covered region. Personal area network PAN, a smallest type network connecting devices within the immediate closeness and individual typical within range of a few meters. Hardware, software, and transmission media used in computer network. Hardware, software, and transmission media are only a few of the related components that make up computer networks and work together and facilitate smooth data transfer communication between devices. Gaining an understanding of unique function of each element is essential of comprehending and the complex operation of this network. Hardware component: routers, cable and connectors, modems. Software components: operating system, protocol suite. Transmission media: wired media, wireless media. Understanding technologies on the World Wide Web. World Wide Web is a network to link publication and resource that may be across over the internet. It is frequently shortened to www or just web. It was created in 1989 by Sir Tim Berners-Lee and quickly established itself as a key element on the internet as we know it today. With the help of server and web browser, it connects web pages via hypertext. Every page has a HTML code and may be accessed by a URL supported by HTTP or HTTPS strands. This system allows for easy navigation and global information sharing. The web is still developing, having an impact on worldwide trend, technologies and communications. Hypertext Markup Language (HTML), the fundamental language for creating web pages. HTML defines the structure and contents of web documents. Uniform Resource Locator (URL), the web address that specifies the location and resources. Example: web pages, images on the internet. Hypertext Transfer Protocol (HTTP) and HTTPS protocol for transferring data between the server and browser. HTTPS adds encryption for secure data transmission. Web browser application that interpret HTML, CSS and Java to read and web pages for users such as Chrome, Firefox, Safari. Web server computer that store and deliver web pages in response to requests from web browsing using HTTPS. JavaScript, a programming language that adds interactive and dynamic behavior to web pages, allowing for features like animation and form validation. Purpose of different types of network topologies. Common types of network topologies: ring, mesh, bus, star. Ring topology. Description: data flows in one or both ways between devices linked in closed loop or circle. Star topology. Description: every gadget is linked to a signal hub or switch. This focal point serves as a conduit for communication. Bus topology. Description: a single cable or backbone connects all of the devices. All devices receive the communication broadcast and each end as a terminator to stop signal reflection. Mesh topology. Description: devices are interconnected, providing multiple paths of data transmission. There are two types: full mesh, every device is connected to every other devices. Parallel mesh, only some devices are interconnected, providing redundancy without full connectivity. Thank you.